Welcome back. And before we start the next presentation, there is a question in the chat window. Was Elie Kfoury question answer? And the question was, did you use a P4 switch as the packet broker? And the answer was no, it was not a P4 switch, the one that is the one that is being used as packet broker. Now, the next presentation, we will spend a few minutes, is a brief presentation about what we are doing here at University of South Carolina. One of the goals, the current project, the project that is being funded in this event from the National Science Foundation, is to do cyber training material. And that's what we're doing with the intro to P4 library, which use BMV2 switches. Now, internally at USC, we're also building a lab library that use the real Tofino chips. Hopefully, in a near future, this will be shared with the community. But it requires a little bit more of work with Intel. But we wanted to describe, and certainly we'll be happy to expand on this after the workshop. So this is a work that is being conducted by Elie and Jose. Elie and Jose are graduate assistants here at USC. So I want to give credit to them. And we're using this virtual platform, the platform that you have experienced when you go through the labs, the hands-on exercises. And we work closely with the network development group. This is one of the leading organizations in virtual training. So we use much of their features, their product called NetLab, and we use much of their features. So what we try to do, as you may have noticed when you go through the lab, we try to build high performance systems. Jose will show us today an example of running pods using the Tofino chips at 40 and 100 gig. The labs that we build shows functional realism. And what that means is that we use real IT hardware or the real code, for example, Linux code that you will use in a production network. We try to make it very easy for an inexperienced learner. So that's the presentation layer, making as easy as possible to navigate through the labs that we build. Also, the platform make it easy to create topologies for complex experiments. We will see today a topology that has multiple virtual machines and real hardware rather than just one single virtual machine. And we're attaching these devices, these physical devices, the Tofino chips, into the academic cloud, into the cloud system that we have here. The picture, how this looked like from our end. Well, when we run lab libraries, when we run an experiment, what had happened is a pod of equipment, for example, pod number 1, Tofino, or the BMV2, the orange, is created so you can run your experiment. And there are several hosts that are hosting these resources. In addition to that, there is one host. These are physical servers that is in charge of managing the whole system. The underlying hardware, CPU, RAM, and storage, and Tofino switches based on Tofino chips. That's what we will see in a second. And we make this possible through these partnerships, as I mentioned before, the network development group, and also VMware, because we have here ESXi running on the host, and vCenter, which is a product from VMware. So we are very grateful for these partnerships. Now, this presentation is about the pods that we're building using the real hardware. So we use these Tofino chips. More precisely, the vendor is EPSCore, and inside these switches we have the Tofino chips. And why do we do this? Well, first, because we want to streamline, make it as easy as possible our grad students and learners in general to learn this technology. And the idea of this platform is to have everything ready. We have to realize that these switches are white boxes. They come empty, and there is a considerable effort required to acquire, install, learn the operating system. We use an operating system that is called Open Network Linux. Acquire, install, and learn the compiler. This is from Intel, and if you need to acquire this, you have to sign an agreement with Intel, and then deploy the equipment, deploy the fibers connecting the switch or switches to the servers, configure the topologies. So all these items require considerable effort. So the idea of building this platform where everything is ready is that a learner who wants to learn, for example, a new student or a network engineer, has everything ready using the facilities that we're building here at USC. So Tofino pods help USC to onboard new students and researchers. That's our case here, so that they can immediately focus on learning how to program the switch. Additional to that, this is a shared environment. That means that the pod is reserved for 2-3 hours, whatever the time is needed to conduct an experiment, and then can be used by somebody else. So the pod is going to be wiped out, clean, ready for the next reservation. For this pod, we use these switches from EdgeCore. The model is Wedge 100BF 32X because there are 32 ports, QSFP 28, and BF has a barefoot Tofino chip inside, and the programs are written in P416. At USC, we also take advantage of the Tofino model. This is a software switch that is provided by Intel that has very nice features for testing and troubleshooting. Specifically, the life cycle of a packet can be traced in the model, and that's not the case of the real switch. So this is the pod. What we do is we attach this pod to the cloud, and by logging in our cloud, making a reservation, this pod is deployed along with the lab manual, lab number 1, 2, 3, whatever is the exercise we want to execute, or if this is for research purpose. So there are some pods that are for research, are configured for our research purposes. How does the pod look like? First, the Tofino model running on a VM, the the hardware switch based on the Tofino chip. This is the EdgeCore, and then we have servers. The servers have a very good amount of memory. As far as I remember, is 256 gigabyte, but we will confirm that with Jose and Elie. They are the ones who are running this. And they have a dual port 100 gig Mellanox cards, which are also programmable, but we're not using that feature for now. We expect to do that in the future. all those lab exercises that you are doing as part of this workshop, similar exercises are available in this Tofino pods. Of course, we're porting the BMB2 code to the Tofino. And I want to switch right now to Jose and Elie, who are the two leading persons that are building these lab libraries. Jose, do you want to share, or Elie, do you want to share your screen?
Yeah, sure, I can share that.
Or as you prefer, I can do also the demo if you want. But
that's fine, whatever you prefer.
Okay, I will let you lead from here.
Okay. All right, so here in this slide, we're gonna show how the platform looks like. So this is like a short video. So basically, this is the topology. We have our servers, and we have a software switch. This is the Tofino model, and we have the hardware switch. And the motivation was to have these two in the same topology. Is that the Tofino model will be basically used for debugging and when you first start writing your P4 program, because it gives you the ability to see how the packet is traversing the pipeline. And then if you want to do like a test where you have high performance, for example, 40 gig or 100 gig, all you have to do is just shift to the other switch, which is the hardware. So the PCs here are Linux machines. They are running Linux, and the Tofino model is as well in a VM, a Linux VM. We tried to do the development environment similar to what we did with the BMV2. All we have to do is just set that we want the environment to be ASIC or model. And if you select ASIC, we have an SSH connection to the hardware, and this is where we're gonna be running all the commands there. For example, here we are running the switch daemon, and we are specifying the program name. And then, of course, you can turn on the ports that you would like. Here we are turning 2 ports, 100 gig. And of course, many of these can be automated. So it depends on what is the purpose of the application you're trying to do here. And then here is where you see your P4 code. You can, of course, modify it, do any kind of programming there. And currently, at this point, we are just populating the match action table with some entries so that we have some forwarding. So you can see like everything is in one interface for editing and compiling and then deploying to the switch. And here we are just testing the connectivity, and this is going through the hardware. So we are going through the Tofino switch here. So we've seen that we have successful connectivity with ping. And here at this point, we are trying to see if we want to use iPerf to generate large traffic. So we want to see if we have a certain application generating a large amount of traffic, if we can forward those using the P4 switch, and potentially if you are doing some in-network application that requires high traffic rates. So this would be a very interesting thing to do. As you can see here with this iPerf test, we are reaching around 50 gigabits per second. So here we just want to make it clear that the bottleneck here is in the senders. So there is some fine tuning that you can do on the senders, specifically with the NICs. And once you do that, you should be able to get up to 100 gig.
Yeah, and again, the nice thing about this at least my experience with my students is that this attaching the devices to the cloud and building this pod is that even my students' intro to computer networks can do P4 in a real hardware with very limited knowledge. But the key is that everything is up and running, is ready. Otherwise, there is a learning curve that they have to follow. So hopefully the idea of this short presentation is we hope that we will have a workshop running the real hardware pretty soon. That's the goal with my colleague, Jason Suraski, and my group here at USC. I don't know if there is any question about this. Okay, there are no questions. There is one question from Jeremy. You mentioned programming NICs. Are those the Bluefield 2? Jeremy, if I understand well, Bluefield 2 is a model of NICs. Would you mind clarifying that? But what I was saying is that the physical pods, the servers have programmable NICs. We are not using yet that feature. We expect to do it in a future.